Welcome to this KontinuumLAB MIDI Melodica tutorial and build video. The KLIK Melodica was one of the most popular instruments in the series when I published the original introduction videos, probably because of its cool 3D printed self-flexing keys. But what most people might have missed is that I also made a sort of scrappy looking cardboard prototype made almost entirely out of recycled materials and which actually works surprisingly well. So in this video I'm going to show you how to make both of them, and as you'll see before the video is over, looks aren't everything. Even if you don't have the KontinuumLAB Instrument Kit, you should be able to make these instruments anyway. You'll just have to source some stuff yourself and of course download the code from the link in the description. Both of these builds use the KontinuumLAB Instrument Kit breakout board, but the Melodica can certainly be put together without it if you have the skills. But if you do have the KontinuumLAB Instrument Kit, then of course you already have all of the electronics and sensor materials that you'll need for both these builds, plus the microcontroller with the code already on it for this instrument and a bunch more. So if you want to get your own KLIK and play along, then head on over to KontinuumLAB.com where you'll find it in the shop. Okay, enough about that. Let's get building. So let's have a look at these materials. Everything you see here in the middle of the desk, of course, is what comes with the complete version of the KontinuumLAB Instrument Kit. And apart from the breakout board here, if you don't have the kit, then you should be able to source all this stuff yourself. I'll put the list up on the screen in a second. And then over on the side we have some materials that you'll have to supply. We have some food grade plastic here. It doesn't actually have to be food grade for this build. I have quite a lot of plastic because we're building the keys out of it and we need some flexible material. I've already marked a little bit the size of the strips that I want out on these egg cartons here, and that's going to work great. And then I have the top of a water bottle, which together with the balloon is going to help me make a breath sensor. Now you see a black balloon here. That's not cool. That was an early build before I figured out that the best kind of balloon for a breath sensor is a metallicized balloon. So we'll get back to that. Then we have some cardboard here, corrugated cardboard, which is great for building structures. And you can see I already marked out the size of one of my structures here. So we have several different sizes. I like this thick stuff, which is a single layer of corrugation, pretty thick. Okay, let's get started on the main structure. So it's no secret that I love corrugated cardboard for prototyping, and one of the reasons is this technique here. Super easy to just break one side of the corrugation and then you can fold the cardboard up to make a pretty sturdy construction like this. So I'm just making a sort of a box shape here, and I don't measure this by centimeters but rather by the number of corrugated waves in each section. So there are two sort of smaller wall sides, and then we have the top and the bottom of the box. Now for a lot of these builds I really improvise quite a lot of this, and this box in particular is going to have sort of a friction fit where this last flap is going to hopefully hold everything into place. As you will see, that actually ends up working quite well, and the breakout board fits inside nicely. So now I'm going to stabilize the bends by just laying down a bead of hot glue inside each one and then folding it back over that hot glue to like a 90-degree angle, or in the case of the flap slightly less than 90 degrees. And that's my preferred method of building with this material. So I'm leaving one angle without glue on it, and that's so that I'll be able to open up the instrument afterwards. Now there are so many ways that you could make this box, so I don't really want to explain the exact measurements here. That wouldn't make much sense, but we're just trying to make something that we can put our keys on top of. So it's going to be a Melodica, of course, and I'm going to use one of these larger surfaces as the base for the keys. Okay, so this is going to be sort of a friction fit, so I'm laying out some hot glue on this surface here, which is then going to go right up against the flap, and that's going to hold everything together. That feels pretty sturdy. Maybe not my best work, but you know, we're just prototyping. Okay, so let's get on with the keys. This is going to be a 16 key melodica, and so I'm starting with 10 black keys, just like I do on my capacitive keyboards, and then on top of that we're going to need to put 6 black keys. So the way these keys are going to work for this melodica concept is I want them to flex mechanically so that I can have an actual contact between 2 electrodes when they flex, when I press on them. So I'm going to use this plastic here, strips that I'm cutting out now, and I'm going to fold them down the middle just to give them a little bit of extra strength, because I think they're too flexible with just one layer of this thin plastic. So now I'm marking off 7.5 centimeters. I managed to not show that on tape, but 7.5 centimeters long, and I repeat that for all 16 keys. And then I of course need some copper tape, which is going to make the electrode. I'm just going to cut across the width of this tape. This is 5 centimeters wide, so you'll see in a bit how that fits together. Then of course now, as I mentioned, I'm folding it not down the middle, rather I'm folding it so that one end is 3 centimeters and the other is about 4.5. Now you can see the flexibility here. And now you can see on the desk there below that one end is slightly longer than the other. Take the backing off the copper tape and then go from the folded bit along the shorter end, and just let the copper tape go off the end there. And so here I'm conceptualizing a little bit to figure out the height of each key. Of course I needed to lift off the other electrode when I'm not pressing on it. So one layer of this cardboard should work just fine, but I want this to last for a while. So this stuff here, if I press on it a lot, you can see it just squishes down and gets a little bit useless. So I'm putting a bead of hot glue on the corrugated end, and that's going to solidify it a lot. Okay, so now I'm pushing a thumbtack through the end of plastic with the copper tape on it, and I'm folding the tape back over it to make contact. I should probably point out that I'm just making a little test rig here just to see if the concept actually works, which is always a good idea before I start making 16 of these keys and trying to figure that all out. So then I make a hole in the cardboard, both layers, big enough for the end of one of the DuPont cables to go through. Then I'm gluing the 2 flaps on the plastic piece together just to shut that so that it doesn't flap around. And then of course I can push the DuPont cable through, press the thumbtack onto the DuPont cable to make contact, and then put the key down in its place and glue it into place. You need to be a bit careful with the hot glue here. If you put too much on there, or if you put the plastic down on it too fast, it will deform from the heat. Okay, so then we run a ground rail that's going to run across all of the keys, so that when you press on any one of them, that's going to make contact with ground. It's going to run right there. And then we're going to put a second layer with another elevated part for the black keys in the back. So you'll see a little bit later how that works. Okay, so at this point I feel relatively confident that this is actually going to work, and so I'm ready to make 16 keys for the actual instrument. So let me just reiterate here. I'm cutting out these strips of plastic. This is probably 0.3 to 0.5 millimeters thick. They're about 1 centimeter wide each. And then I'm making some 7.5 centimeter long strips, and I'm folding them so that one end is 4.5 centimeters and the other end is 3 centimeters. Then I get some copper tape. I cut some full widths of it, that's 5 centimeters long. Make it a bit more narrow than your actual plastic strips, and then I put them onto the short bit so that they go from the folded end and stick off the open end. And then through the part that is on the open end of the 3 centimeter long piece, I stick some thumbtacks. Then I fold the copper tape back over the thumbtack, and then I glue the whole thing shut, and that's basically the key. Then it's ready to apply to the instrument. So I hope it's clear from watching my process here that none of these measurements are absolute in any kind of way. I mean, this could have all kinds of other shapes and sizes. You could use different materials. You need something with some flex on it. Then you need to make electrical contact. This specific prototype here uses the thumbtack method, and as you can see here, I'm using a piece of corrugated plastic to squeeze it through. So have a good look at the keys here. This is actually probably the best angle you get. These now have the tape running off of the 3 centimeter long end on the underside, and then they fold back over the top side where the head of the thumbtack is. Okay, so now it's time to put the keys on there, the first row of keys. And of course I just sort of improvised this pattern on there, and now I'm using the thumbtacks in the keys to mark the position that I want each key to go on. There, that's the whole row of quote-unquote white keys. We take those on there and use the holes to guide us in the process. Of course, I'm going to have to put an extra layer of corrugated cardboard on the back of this top surface, get some hot glue on there, and then just stick it on. I'm leaving a gap in the front for the flex of the keys of about 2.5 centimeters. And now I'm putting some hot glue on the edge of the corrugation just to strengthen it, like I mentioned before. Okay, so that's looking pretty good, but now I need to make those holes bigger where I put the thumbtacks through before. There you go, and they need to go through both layers, of course. That's where the DuPont cables will fit through afterwards. And now I'm numbering all of these holes because that'll make the connection to the multiplexer much easier later on. Let me just drop a quick graphic of how the numbering is for all of the 16 key keyboards in the KontinuumLAB Instrument Kit. These are the correct numbers. As you can see in the footage though, I got the numbers wrong when I was making this instrument. The reason why I start at 0 instead of 1 is simply because the multiplexer modules I use in the KLIK count that way, starting from 0 and going up to 15. It's not really a problem, I'll just make sure to get them in the right order when I plug everything in, from lowest to highest. Okay, so let's close that up and have a look at it. Looking good. So before I put on any of the keys, I'm going to apply the grounding strip. I'm just going to stick that on there and leave a little flap loose because I'm going to again connect a DuPont cable with the thumbtack, and I want to fold the tape over it for better electrical contact. So let's make a hole for the connection, and we'll call that G for ground. And that's the first connection I'm going to make. So let's put the DuPont cable through, then we need a thumbtack in there, and then we can fold the copper tape back over it there. So I'm just going to put some hot glue on the inside of the cable here just to stabilize it, because I'm going to be moving this around still a lot. I'll also put a little bit of hot glue on top just to keep that flap in place. I could do this with a piece of tape, but this will also work just fine. Okay, so now I need a bunch of cables. I'm using these 20 centimeter DuPont cables, and I need 10 of them for now. I'm going to connect each thumbtack to a cable. First push the cable through from the inside, push the thumbtack onto the cable, and then pull everything into place. And then the next thing to do is to glue all of these keys into place. Again, make sure that you don't put the hot glue on there and then immediately stick the plastic down on it, because the heat from the hot glue will deform this thin plastic. So just pay attention to that and you should be fine. Make sure that they're all pointing more or less straight ahead and at the same level with the grounding strip. And there, that's all 10 of them, looking good. So yeah, they work just fine apparently. Make contact and lift off when I let go. So next is time for the black key. So I'm going to have to build up 2 layers here. First I'm going to have one layer where I'll put the grounding strip, and then I'll put another layer with a thinner strip of cardboard to hold the actual keys so that they can bend down onto that grounding strip. This will also give more or less the same difference in height as on a regular piano. Not that that really matters in this case, but so this is what that construction is going to look like, and this is where it's going to sit. So we need to do the same thing as before. I'm going to use some actual keys here to make the position marks with the thumbtacks. You can see where they go. And then I use this tool here. It could be any sort of pointy tool to make some bigger holes, big enough for the cables to fit through. Again, I need to grab this main strip here where the keys go and just strengthen the edge of the corrugation with some hot glue. And then of course I need to glue the 2 pieces together. And again, I'll probably have to remark those holes just in case some hot glue got into some of them. A lot of it got onto my fingers. Okay, so next I'm going to actually also number the black keys here on the inside, just to make it easier to connect everything when I get to that part. I think we can just have another look at that graphic from before for your viewing pleasure. Okay, so then I'm expanding those holes in the inside to make sure I can fit everything through, and then I'm gluing my new top piece down on top of the whole construction. I can use the holes as a key to make sure that everything is in the correct position. Okay, and once that's set, I'm ready to put in the actual keys. So for the black keys, I changed everything around a bit. Now this time I'm pushing the cables through from the outside with the key already connected to it. It was just a different experience here. The cardboard is much thicker at this point. And I also put the grounding strip on after the keys. But of course these details aren't terribly important as long as you can fit everything together. Move the keys out of the way. Put the strip down where it goes, make sure I have that extra flap that I can then fold back over a thumbtack, then I make a hole through the whole thing. Then I connect a cable to a thumbtack and I pull that through, and then I fold the flap back over it. Just like before, I stabilize everything with a little bit of hot glue. And then it's time to glue the black keys into place. I call these black keys. I mean, you could, paint them black if you want. I don't really care very much. Okay, finger test. It's certainly very weird, but I mean, it feels pretty good. The keys have some nice flex to them, and I'm pretty sure this is gonna work. Okay, so time to apply some actual electronics. I'm going to use the KLIK breakout board, a multiplexer, and this 8-contact DuPont cable to connect them. So before I connect anything, I want to just figure out where to put the breakout board, because that's going to define where the USB cable sticks out. So I'm deciding on that side there. And yeah, that looks pretty good. So I'm going to just glue this down. Gluing this breakout board down on cardboard is not a problem. If you want to take it apart, you can just peel the hot glue off the back of it again. Next is time for the multiplexer. Let's just get that cable in there. I'm also going to glue this into place. Instead of the base, I'm going to glue this into the back wall of the instrument. And then I start connecting stuff. So I'll show you the graphic of the actual connections in a second, but just notice here that this ties into what you saw before, the keyboard with the numbers on the keys. These same numbers are the numbers that you'll find on the multiplexer as you connect each cable, and that's going to assure that the signal from the right key goes to the right place. And then of course the ground strips here need to each be connected to the ground part of the power rail on the breakout board. Pretty simple stuff really, even if there's quite a few cables in there. Okay, so let's just fold these cables back a bit here so we can close it up and have a look at it. Looking pretty good. So that's basically the whole keyboard section of the instrument finished. Just testing it out a bit. And now I'm getting ready to make the breath sensor. Of course, this is a melodica, not just a keyboard. And so we're going to have a breath sensor on here. And of course, as you might have seen, if you get the complete version of the KontinuumLAB Instrument Kit, you get also this very cool 3D printed breath sensor here. But I'm not going to use that for this primitive prototype. Rather, I'm just going to grab the CNY70 module and make a breath sensor from scratch using this bottle top and a balloon and a rubber band. Okay, just hold on there for a second. It's time for a short rant on the subject of balloons. Bear with me, this is useful and important information. See, all of the KLIK breath sensors, as well as other membrane-based instruments, use a membrane made out of balloon material to reflect the light from a CNY70 sensor to allow that sensor to measure the change in distance to the membrane as it expands under pressure. Now, there are many types of balloons in the world, but for this purpose, not all balloons are created equal. The best possible balloon you can get for this kind of use is a metallized one, like this. To make a long story short, I've gone through a lot of different kinds of balloons since I first started making membrane-based sensors. And when I finally figured out this fact, after finishing all the KLIK prototype instruments, I felt incredibly stupid because it's so obvious once you know it. The two important parameters are reflectivity and opacity. So that means getting good strong reflections from the CNY70 sensor's light while blocking all external light sources. And this is simply the best way. Now, there are special cases. For example, if your breath sensor is inside an instrument with no external light reaching it, then any bright colored balloon will do. But a silver one like this will work under all circumstances. So that's what I recommend. My point is simply that for the rest of this video, as you watch me use the black balloon, just ignore that, okay? And one more thing to keep in mind, if you do substitute in a metallized one, then of course the distance between the sensor and the membrane will need to be greater because of its greater reflectivity. Something like 8 to 10 millimeters should do nicely. I actually went back after the fact and implemented that in this very melodica, as you can see here. Okay, enough about balloons. I go into much more detail about this in the KLIK breath controller tutorial, so you can go check that out if you want to know more. Let's get back to the melodica build. Okay, so now we cut down the bottle top basically as low as possible while still leaving a bit of a flange on there to hold on to the rubber band. Make sure you don't have any sharp edges on there which could damage the balloon membrane. Next we take off the cap, and I'm making a 7mm hole in here. If you get the complete version of the KontinuumLAB Instrument Kit, you get some 8mm silicone tube with that, and a 7mm hole is very good for that. You could also just blow directly into the breath sensor itself, but for a melodica I prefer to have a tube sticking out. So this is just one way of making the bottle top breath sensor, but this is going to work just fine. Next we need to prepare the membrane, and so I'm just cutting the mouthpiece off the balloon here and cutting basically the balloon into 2 halves more or less, and then I can use one of those halves to stretch over the opening in the breath sensor and then put the rubber band on top to hold it in place. And so as you can see now, that's the membrane, and inside of here is the pressure chamber. So once we get the tube in there, I'll show you how that works. The balloon expands when you blow into the pressure chamber, and that's what we're going to measure with the CNY70 module. So I'm making a little nick in the tube here, a little hole for the pressure to escape through, so that I can blow in it in a continuous fashion like this. That works great. Now another way of having the air escape hole is to actually make a secondary smaller hole in the actual pressure chamber, like in the bottle cap, and then you can either just have the air escape through there or put in one of the thinner silicone tubes and guide that air wherever you want. Then of course you put the CNY70 module in front of the balloon membrane, and that way you can measure the expansion as you blow into the pressure chamber. Okay, so next I need to fit the breath sensor inside the instrument. This fits great. I'm going to put a little end piece on the whole structure here in order to hold the breath sensor in place. So I'll just cut out an extra piece of cardboard to size. That's going to fit in there like that. Cut off the top piece to make sure it fits with the lid. And then of course I also need to cut off an extra piece here so that I can fit the flap into place, which is what holds everything shut. So this is all very much improvised. There are better ways of doing this. You could probably think of one in a second, but that's how I'm doing it anyway. So now I need to make a hole for the breath tube, and that goes like that. Doesn't need to be pretty. It has to be a little bit thicker than the silicone tube. I find a pencil works pretty well for that. Okay, nice. Then of course I'm going to glue everything into place with hot glue. Put that end piece in where we want it. And strengthen the edges of it a little bit with some extra hot glue, just so that it will last. Then we can draw the tube out from the inside. Looks nice. Let's close it up and have a look. Okay, it's starting to look like a melodica. Very cool. Next, we need to fit the CNY70 sensor in there. So in order for the pressure chamber to not flop around, I'm going to cut out a couple of pieces of cardboard here and glue them into place in order to hold the pressure chamber in place. Because of course we need a constant distance between the pressure chamber and the CNY70. Now this little platform here is going to hold the pressure chamber perfectly in place, but I'll still be able to pull it out if I need to, which I will need to because at some point I have to change the balloon. It's also going to work as a little platform for the actual CNY70 sensor, which will help me to hold that in a fixed position relative to the breath sensor. I'll make this little triangle piece here, and that flat vertical wall is where I'm going to put the CNY70 sensor module onto. Just like the multiplexer and the breakout board, I'm simply going to glue the CNY70 sensor module onto this piece of cardboard here. First I just figure out where I want it to go. Then I put the sensor on there. So I've picked a height which will more or less put the sensor right in front of the middle of the membrane, which is where we get the most flex when I blow into the sensor. So in this case here with the black balloon, I'm putting this very close to the balloon, about 3 millimeters, which works for a shiny black balloon. Of course, if I was using one of the more adequate metallicized balloons, I would want to put this at 9 or 10 millimeters distance maybe. Okay, next is time to connect the sensor to the breakout board, and back when I made this build, the connections weren't the same that they ended up being, so this is not where that plug goes. Let's have a look at the connection graphic to make sure we get this right. So the final thing we need to make this work is the calibration button module. And I wanted to just point out that in the KontinuumLAB Instrument Kit you get two kinds here. There's one that has the pins off to the side like this one, and one that has the pins going vertically downward like this one. In one scenario I want the button to be on the outside, like on this MIDI Ocarina prototype from the previous tutorial. In that case I want the cables to disappear straight into the instrument body rather than flopping around outside. The other use case is like in this melodica that we're making today. Since I have a partially open instrument body, I can reach inside to activate the calibration button. So with the button installed inside, I obviously don't want the cables to stick through the instrument wall because they would end up outside the instrument, where they would again just flop around and be in the way. Like I said, the same goes for the CNY70 modules, and that's why the KLIK contains both varieties of both modules. So in this case I'm going to go with the one that has the pins off to the side, and I'm going to put the calibration bottle on the inside, right here on this side wall here. So pretty simple again, just like the other modules, I simply glue it into place with hot glue. Let's put the cables in there first, make sure you point the cables inwards, and then we just put it down there and hold it into place till it sets. Then we can grab the double cable here and plug that into the breakout board as well. But of course there's still one very important thing missing, and that's the microcontroller. So I'm just going to grab this one here from this previous build, the Ocarina, and plug it straight into the breakout board in this new instrument. The point of course is that if you bought the KontinuumLAB Instrument Kit, then this microcontroller already comes with all of the instruments programmed onto it. So all you need to do is just insert the right jumpers on the breakout board to make sure that the software knows which instrument you're actually building. So let's just have one more look at the connection graphic here just to make sure. Okay, so that turned out surprisingly respectable. In the spirit of this improvisational build here, I decided to put a hand strap on it like a lot of melodicas have. This is totally improvised, just like most of this build, and I'm making it out of cardboard that I'm just strengthening with some gaffer's tape here, Gorilla Tape, whatever this is. And yeah, it's pretty self-explanatory and not very pretty, but so I'm making this strip here. It's about 2 centimeters wide. I just crushed the cardboard along its whole length to make sure that it was flexible, and then I just wrapped this tape around it. Then I'm scoring the tape and the cardboard where it's going to go, which is going to help me to make a strong bond when I hot glue it onto there. And then I'm just gluing just the end, and then folding the strip back to glue the other end into place as well. As you can see, there's a good bit of material left over, which is where I'm going to fit my hand through, of course. So yeah, I know that looks really weird, but it's actually surprisingly comfortable, and it's pretty strong. So looking good. I think now it's finally time to plug this guy into the computer and see if we can make it work. First we calibrate. The Melodica is a bit of a special case here because we only calibrate the breath sensor. These keys are digital and don't need calibration, but we will need to reset the instrument after we calibrate because of the way the keys are read. Anyway. Okay, save the calibration. Good. Then we reset. And now we're good to go. Nice. Works great. And there you go. I think this is really a clear case of ugly duckling syndrome. This instrument honestly looks like a pile of junk, and yet it works perfectly. This is the kind of stuff that I really enjoy. Basically the definition of prototyping as far as I'm concerned. Once you make something like this and it actually works, you're much more well prepared to take it to the next level with confidence and invest more time and materials in subsequent builds. So that's what I did, and that's what I'm about to show you. Let's do it. Okay, let's get started on the second build. This is quite a lot more involved. One main difference is that we are going to be soldering in this build, unlike the previous one. And of course, we're also doing a 32 key keyboard, so there's going to be basically twice as much of, well, almost everything. So even so, this middle section here represents stuff that does come with the complete version of the KontinuumLAB Instrument Kit, including this 3D printed breath sensor, which is the same one that was inside the ocarina that we did in the previous tutorial. We could of course also use a bottle top breath sensor like we did in the other Melodica, but we're not going to. The main new element here are these 3D printed keys here. These are self-flexing 3D printed keys made in PLA, and they're going to do the job that the flexible plastic did in the previous Melodica. We also have these box ends, which we're going to talk a lot more about. These are going to help us to make the main structure, to make it a little bit more serious looking and sturdy than the other cardboard version. So they have some handy cutouts for stuff like the button module and of course the USB cable, as well as the silicone tube for the breath sensor. We're also using this corrugated polypropylene here, also known as fluted plastic. This is roughly 5 millimeters thick, and it's what we're going to use for the main body. Okay, so in this case we're going to start by trying to make the main body of the instrument, and rather than measure the exact width of how big I want it to be, I'm going to use the actual keys here to figure that out. Now if you do download these keys from my link in the description, then you will notice that they're all named by the note that they play. So they're all a little bit different, and you would need to put together a set yourself. So I'm lining them up here with about 1 millimeter space in between each so that they can move freely, and then I'm just using that as a basic measurement. Then I'm marking everything out on the corrugated plastic so that I can cut that out using those measurements. This stuff is really easy to work with. You can cut it with a Stanley knife, but it's pretty strong and sturdy and stiff because of the corrugated pattern. So the way we want to work this is pretty much like the cardboard. We want to make some cuts in it so that we can bend it around the box ends. And the box ends, of course, are going to make up the ends of the box. And then this stuff is going to make the main body where the keys will rest on. Now, if you saw my ocarina tutorial, then you'll know what I'm doing here. I'm cutting out some pieces of the corrugation on one side of the plastic. Specifically, I'm cutting out 3 lines here and then removing 2 little sections, the ones that you can see here when I open it. I'm going to remove those 2 little sections, as you can see in a second. and that's going to help me to bend this, giving some nice round corners around the edge of the box ends. Now, pay attention here. Corrugated plastic doesn't always come with the exact same measurements, so the corrugated pattern might be larger or smaller. Sometimes I've bought stuff that I needed to cut out 4 sections of to make it work. So I can't give you the exact measurements here or the exact number of corrugated slots, because the stuff you buy might be slightly different. What I will say is that here the short end here is about 2.5 centimeters wide, and the longer top side is about 8 centimeters wide, and that's going to allow the keys to fit on there comfortably. And of course, that's the measurements that I found would fit around the box end. So we're going to do the same operation on the second cut, and in a second you're going to see why this is so cool when we fold this up. So that we do the third cut as well. Exactly the same operation. Be careful not to cut through the opposite surface, because that would mar the exterior of the instrument. Okay, so that's looking pretty good. Of course I checked these measurements beforehand, but you can see how that fits together. Normally, rather than using a ruler to measure these things, I actually put the instrument up against the box end, and I just mark where I can see that I'm going to have to bend it. I might make a video specifically about these box ends, because I use them in a lot of instruments, and there's a trick to using them, but they're very, very handy for this kind of construction. So now I'm showing you here that I'm going to only glue the material to the box end on 3 sides, and then the 4th side is going to be the lid. And to help the lid to keep closed, I'm making a little flap at the end. Well, not a little flap, it's also about 2.5 to 3 centimeters wide, and that's going to fit inside the instrument. You'll see how that works. Okay, so here's the full piece of exterior material. Now you can see how that fits together. And because of the way the box end is made, I'm going to have to cut off a little bit of the flap. About the same width, of course, as the box end itself, because it's going to have to go past the plastic and fit inside the instrument. I swear this is going to make really a lot of sense once you see how it all fits together. So if you download these box ends and you print them out, then it's really pretty self-explanatory. I also use this in a few other tutorials in different sizes and measurements, so you'll be able to see how that works. Now I can see I made this flap too long. It's actually touching the bottom of the inside of the instrument, so I just cut off a little bit of it, put it back together, and yeah, seems to fit really well. So now you can see how that fits together. That inside flap is going to be loose. The top that you can see here and the inside flap, they're going to be loose, and they're going to make up the bottom of the instrument. And then the top side will have the keys on it. I made this little structural piece here because I thought it might be necessary to hold this long instrument together, longer than some other stuff I've made. But it finally turned out to not be necessary. So, you know, we're going to just leave that. What I'm doing here is I'm scoring the polypropylene a little bit just where I'm going to glue it to the box ends, and that's going to help the hot glue just to hold on between one piece and the other. The hot glue isn't hot enough to melt the polypropylene, and of course it doesn't provide a chemical bond at all, so scoring the material is always a good idea. The 3D printed part is different because it actually has some texture to it, so it sticks to the hot glue quite well. So after applying hot glue to both sides here, I'm now just making sure that all the pieces fit together properly and the bends can be performed while I put the end pieces on there. So the first thing I do is I put each end piece on there glued to just one side, and then afterwards I will fold up the necessary flaps and glue those in place. And right now I'm just using the flaps to measure the correct position of the box end piece. Okay, that's it. Now the box ends are on there. Now I'm going to take the first bend and I'm going to put that into place and glue it in place. Again, I'm making some structure, some holes, and scoring the polypropylene in the bend because I'm actually going to apply some hot glue right in there, which is going to help a lot to keep things structural. Now I'm just putting some blobs on there, not a full bead, because I don't want to spend like a liter of this stuff. But keep in mind that you don't want to skimp on hot glue here. This is under tension, so you really want it to just be held in place by a few pieces of hot glue. Keep in mind also that you're actually defining the corners of the bend here as you go along. It can be sharper, it can be softer, it can follow the bend of the box end piece to a greater or lesser degree. So try to make it neat if you want, and if not, well, it's gonna work just fine anyway. Okay, so now I'm removing a little bit of the hot glue on the inside here, just so that things can close up once I'm done with the structure. So we repeat this operation for the other side. We're going to put some hot glue globs in there with the little structure in the polypropylene, and then we're going to glue it to the box end piece. Make sure you work fast here. You don't want the globs of hot glue to set before you're ready to bend the whole thing together. So then we bend it up. Make sure to hold everything in place. Try to make it as neat as possible. And yeah, it's looking pretty damn good. So that's it for the glue job. Now the rest of the main polypropylene piece here is going to be the lid. And the fact that the flap folds inside the instrument actually helps a lot to just hold everything together. Pretty handy. Yeah, so it's actually a bit of a tight fit, a little bit hard to open up, but still, you can open it up. It's not really a problem. And you could also just cut off a little bit of plastic if you wanted to make that easier to deal with. So you can see how that fits together. Pretty neat solution if I do say so myself. Okay, time for the tricky bit. We're going to have to fit these keys on there. Now, of course, I used them to make the measurements, so I know that they're going to fit. But still, we need to put them on here individually, make the electrical connections, glue them all down in a useful way, which is going to make them stay on there in a sturdy fashion. So I'm just spending a little time here thinking about stuff, and then I start marking out the positions. As you can see now, I've already marked the positions of all the keys here, leaving about 1 millimeter, maybe 1 millimeter and a bit in between each. And now I'm making a secondary mark to figure out where the hole for each electrical connection is going to go. And then I'm making those holes. I make the hole right in the middle of the front end of each key. If you look at the keys, you'll see that there's a little dip in the structure of the 3D print, and that's where we're going to solder the cable onto the copper tape. Then I'm doing the same thing for the black keys, of course. They also have a little dip where we'll solder the cable onto. You'll see that in a second. Okay, so now I'm thinking about numbering these keys. There's 32 of them, and I want to make sure that I plug them in the right order. Starting on the left-hand side, we will go to multiplexer number 1, connection number 0, and then once we get up to 15, we'll start with multiplexer number 2, and I'm just numbering from 0 and all the way up to 31. That will make it much easier once we get to plugging everything in. Okay, so before I start pulling cables through and soldering connections to the keys, I want to figure out more or less where the electronics go on the inside. Because once we get all those cables in there, it's going to be a bit of a mess. So we need the breakout board, and we need 2 multiplexers. And we need, of course, to connect the 2 multiplexers to the breakout board. And then we need a bunch of separate cables for the individual keys. And I'm trying to just figure out what length of connection cable I need for the multiplexers. That depends on where I put each of them. So I'm going to put one in one half of the instrument so that the cables from the individual keys don't have to be so long, and then I'm going to put the other one near to the other half of the instrument for the same reason for the other half of the keys. So now I connect the 2 multiplexers. The multiplexer closest to the microcontroller on the breakout board is multiplexer 1, and the other one is multiplexer 2. So if you pay attention here, multiplexer 2 is on what is going to be the right hand side of the instrument, which is where the higher numbered keys are, which are going to connect to multiplexer 2. Okay, next up I need to make the ground rail, just like I did for the previous Melodica, and that works exactly in the same way, but we need to make it a little bit longer here so that everything can reach. I'm gluing that down in between the holes for the white and the black keys, and I'm folding it back on itself so that I have a loose flap at one end, and rather than use thumbtacks here, I'm going to actually solder a cable onto that. Okay, so next up I need to start preparing the keys. Now, if you look at these keys, they have a sort of a cutout on one side, and that is meant for the copper tape to run through from the top side to the bottom side. And I'm using 2.5 centimeter wide strips of copper tape, and I'm cutting those in 2 in this slanted fashion here. So you'll see in a second why I'm making this shape. Let's get the backing material off, open up the key, not too much because you might break it, and then you just stick the copper tape onto there. So we have on the top side of the bottom part of the key, we have these two pieces that do not touch, okay? And those are the flat sides of the cut, and then the slanted side of the cut will go down into this bottom section here, and that's where we're going to solder the cables to. So we need two cables for each key. Then on the top side of the key, on the bottom surface, we're going to put a piece of copper tape. I'm not sure if I did that on the first go, but later on I think I did. I took that off, and I actually make a little bit of a pad just to give it a little bit more softness, which helps make a better connection. And I'm using some gaffer's tape here. I'm making some small squares, and I stick that exactly where the copper tape is going. Okay, I can see actually I did it the other way around. I stick the copper tape on top of that, and then I stick that on the bottom side of the top piece of each key. So that once you press the key down, it's just going to make an electrical connection between the two copper tape pieces that we put on there before. So it's a really simple electrical circuit, and as I mentioned, this turns out to be not 100% stable. You actually have to press a little bit hard on this to make sure that it works. So I might revisit this at some point in the future, but for now it actually works. Okay, so now we need to prepare the cables for the individual keys. I'm making a long cable and I'm making a short cable. Now if you have the DuPont cables from the KontinuumLAB Instrument Kit, then maybe you can take a 30 centimeter cable and cut it into a 20 centimeter length and a 10 centimeter length. And then you have a connector on one end and just a piece of cable on the other. And you can solder that bit of free cable to the copper tape here. Doesn't matter which one you solder onto which, as long as you solder onto both of these pieces that go on the bottom of the key. Excellent. So then we push those through the holes that we made in the main body of the instrument. Oh, careful with the electronics there. You can see they both fit through the same hole, and then we can just put the key down there. And because we have the cutout on the bottom of the key, we're able to push the key down so that it sits flush with the surface of the instrument. And there's the action of the key in action. And so I'm feeling pretty good about that. And now it's time to get down to business and make the rest of the keys, 31 of them to be exact. I do this almost on every build. I first do one just to check out that my logic is sound and the pieces fit together and work. And then I like to work in a factory fashion for the rest of them. Sometimes it's 16, sometimes it's 32 or more. So here I'm cutting out all the pieces of copper tape first for the larger white keys, and or in this case they're blue keys, and also the pieces for the top side of those keys, and of course all the gaffer's tape, which in the future I might do this with a different material. Then I do the same thing for the black keys. We're using some smaller copper tape pieces there. If you have these keys, then it's pretty easy to figure out what size you need for each. Then, as you can see, I'm cutting some 300 millimeter DuPont cables into 30 and 10 centimeter lengths so that I can make the short and long cable for each. If you have the KontinuumLAB Instrument Kit complete version, then you have plenty of these cables and just go for it. If not, they're really easy to source. You can buy them online or whatever. Then it's on to soldering, a lot of soldering, getting all the cables on there. And this is a little bit tedious, but of course you've seen the final result, so you know that it's worth the effort. You end up with a very cool looking instrument. And oh, by the way, actually when you solder the shorter cable to the key, you can see here that it doesn't have a DuPont connector at the other end. It also has a bit of copper sticking out there, and that's because it doesn't plug in anywhere. It actually solders to the ground rail, so you don't want a connector on that, only on the longer one. And so now I need to fit all of these onto the main body in exactly the right position. As I mentioned, just like on a real keyboard, these are all slightly different. As you can see, I've numbered the keys with exactly the same order as I have on the actual body of the instrument. And in order to stabilize these cables here, I'm putting a little bit of hot glue on top of the cables inside that dip in the 3D print. And then I'm just wait till it cools down a little bit, and then I'm squeezing it into there. I want to make sure that you don't have any hot glue sticking up out of the hole, because that wouldn't allow, then that way you wouldn't be able to put them up flush against the instrument body, and you want them all to be at the same level. So One good way to do this, as you can see here, I'm actually wetting my finger. So I put the hot glue on there, and then before it sets, I wet my finger and I can squeeze it into the dip in the 3D print. That way I don't burn my finger, and I'm able to get a good flush surface on the key, and the hot glue will stabilize the cables a lot. The black keys don't have any numbers on them, and that's of course because they're all exactly the same. It doesn't really matter where they go. So you just need to keep track of the blue keys really carefully and make sure they go in exactly the same place. Now I'm doing the same as I did when I bent the main body into shape. I'm making some holes here underneath where each key will go, and that's going to help the hot glue that I used to glue it down to hold on to the 3D print. Now, let me just point out that you could make this instrument on any kind of box. If you use a wooden box, which would be really cool, then of course this is not a problem. I mean, you would just glue these keys down on top, make some holes with the drill or whatever. But I like this material. It's very flexible. I use it to make many different instruments in many different measurements and sizes, and so you really need to pay attention to gluing stuff onto it, because it is very, very smooth material with no inherent texture. So now you can see I'm making sure that I glue these down with a bit of space in between each, like I said. And again, it's a bit tedious, but of course through the miracle of video editing, I'm already done. Okay, and now we look inside here, and it's a real rat's nest. And what I need to do now is I need to get all of the short bits of cable and glue them down onto the ground strip that I put into the middle here. It's a pretty easy job. Of course, I already made sure to put a little bit of solder on the end of each of those cables, and now I'm also putting a glob of solder onto the copper tape before I start soldering. And this is going to allow me to make each solder spot really quickly, rather than having to hold the soldering iron on there for a long time. And that's going to make sure that I don't start melting the plastic underneath. As you can see, making these solders on this copper tape is extremely easy. It accepts heat really well, and then everything, the solder melts on both ends really quickly, and you just pull away the soldering iron and you're done. So in this case you can see it's already deforming a little. That's because the plastic underneath is melting a little bit. The good thing about this corrugated plastic, of course, is that it has two layers, so it won't affect the top surface. And there you go. All of the short cables, all 32 of them, are now soldered to the grounding strip, and it's time to start connecting the rest of the cables to the multiplexers. So this is where having numbered those keys and cables is going to help a lot. Just to keep everything organized and make sure it doesn't rattle around when I play the instrument, I'm going to glue the multiplexers down as well. No need to really prepare or score the polypropylene for this, because there won't be any sort of mechanical forces involved. And also, if you want to use these afterwards or something else, it's pretty easy to take them off of here and peel the hot glue off of the component. Okay, so now I start plugging. First of all, the first key on the left hand side goes into pin 0 on the first multiplexer, and that way all the way up to number 15. And then you start with the next subsequent key and start plugging in from pin 0 on the next multiplexer, multiplexer 2, which in this case is the one that I put closest to where the breakout board will go. And this is a little bit finicky, but not really difficult as such. Just, again, a little bit tedious. All of the instruments that I make with 32 keys have a tedious element to them. That's just the nature of the beast. Okay, so now I'll connect the two cables here to the multiplexers. These handy 8-pin cables also come with the complete version of the KontinuumLAB Instrument Kit, but if you don't have them, you can just use 8 separate cables, as long as you make sure you plug them in the right order. Okay, so now we're basically done with the keyboard portion of the Melodica, and now we need to make the breath sensor. Now in this case I'm using this 3D printed breath sensor that you can download from the link in the description, and which also comes with the full version of the KontinuumLAB Instrument Kit. I'm using the same techniques that I showed you in the Ocarina tutorial, so we need to make a disc roughly the same size as the surface of the breath sensor, out of some kind of food grade plastic material. And we bent that in the middle and we put it inside a water balloon like you can see here. And that's going to help stabilize the water balloon as we blow into it through this silicone tube. See how that works? Okay, so that's very nice. Now we just clamp these two pieces together around the water balloon, add the CNY70 sensor module, and that's the whole breath sensor. In the Ocarina tutorial there's an example of how to do this without the 3D printed part, and I'll put some links in the description to help you work with the CNY70 sensor. Okay, a word on mouthpieces and breath sensors before we continue. Now, when I built this Melodica, this breath sensor design was still very new, and me from the past was still very much in love with it. But since then I've grown more and more fond of the bottle top design, which is the one that I used in the previous Melodica build that you just saw a second ago. Now this design is by far the easiest to put together. It can be made completely DIY with recycled materials, and furthermore it has the best sensitivity and responsiveness of any breath sensor I have ever tried. Also, it can function both as a breath sensor and a mouthpiece without the need to add any tubes or other stuff. Here's a little standalone breath sensor just for sensitivity testing. Try some trilling or flutter tonguing. That works. How about this? I get into more detail about mouthpieces and breath sensors in the tutorials both about the KLIK as well as the one about making standalone KLIK breath controllers. Anyway, as I've mentioned before, all of the KLIK breath sensors are completely interchangeable, so just try not to worry about it and put whatever CNY70 based breath sensor on there you like. So we need some long cables because this instrument is long and we want to go all the way from one end of the instrument where the breath sensor will go and all the way down to the breakout board. So I'm using these male to female DuPont cables to extend some of the standard DuPont cables that I use. And then we just plug this triple cable into the CNY70 sensor module. We pull our tube through here. I'm using a long silicone tube because I want that Melodica feel where I can blow sort of from a distance. And then I'm just plugging that triple header into the breakout board in the place that you just saw in that connection graphic. Okay, final thing here, I'm preparing the silicone tube with a little escape hole. It has to be smaller than the diameter of the tube, and it's going to allow some of the air to escape so that I can blow in there continuously, which is a more natural way to use a breath sensor. I also need to connect the ground strip on the instrument to the breakout board. The breakout board has ground and 3-volt connectors on it, so I'll take one of the DuPont cables, strip off one end, and then solder that to the ground strip and plug it into one of the ground terminals on the breakout board. And then of course the final thing I need to do is connect the calibration button module, just like on all of the KLIK instruments. Now in this case I'm using these box ends, and they actually have this handy little hole here where the button module fits into perfectly. So as usual I just glue it into place, making sure that I don't get any glue on the actual button, which would be a problem, and then I can just plug the double header into the calibration button connector on the breakout board. But of course there's one crucial thing still missing, and that's the brain of the instrument, the teensy microcontroller. So I'm just going to grab it from this earlier Melodica that we just made and put it into this new one. Keep in mind that there's one big difference here on these two instruments, and that's the number of keys. So of course we need to make sure that we select the right options on the breakout board so that the chip knows what instrument we're building specifically. Have a look at the graphic for how that fits together. So the final touch here is that I want to glue the breakout board down inside the structure. But unfortunately the camera cut out in the middle of this operation. But as you can see, I'm first putting in the USB cable and then I'm putting the glue. It's me from the future to the rescue again. Let me show you how this works. First we'll just undo the glue job that's on there, like that. Peeling off the old hot glue from the PCB is not really a big deal. Now we apply hot glue to the breakout board again. Then we pass the USB cable through here and plug it in. Next, We close up the instrument, making sure to align everything more or less right. Hold onto the USB cable to hold everything in place while the glue sets. Then we wait. And then we can unplug the USB, open up and see how it looks. There you go. What I did manage to film was this moment here about a week later when I changed the instrument to accept this other breath sensor here. This is the bottle top breath sensor and mouthpiece, and I designed and printed this new box end here to accept the mouthpiece holder, which is also 3D printed. Very handy setup. So what I need to do, of course, is remove the old breath sensor. We won't be needing that anymore. And then the connections are going to be exactly the same because, of course, I'm still using a CNY70 sensor module. Then I need to remove the old box end. As you will probably remember, we just hot glued that on there. So once I get all of that hot glue more or less cut out, I can just peel it right back like this. So this isn't going to spontaneously fall off, but once you cut through all of that hot glue, then you can remove the instrument and then you can remove a lot of the hot glue, and then the gluing operation is exactly the same as before because the piece is exactly the same except for this much larger hole. So we just glue that in there. So here you can see the mouthpiece holder without the bottle top in it, and it already has the CNY70 module in it. So then I cut out a balloon. This is not just a black balloon, mind you. This has a white print on it, which works for a nice reflection from the sensor. So that's actually not a bad solution. And that's what I'm putting in here. Then that fits right into the mouthpiece holder. And of course the bottle top has been cut exactly to size so that it fits. And then everything is held together with rubber bands. The connections are exactly the same. Make sure you get ground connected to ground, and then that's going to work just the same as the other breath sensor. Finally, I'm just inserting some silicone tubes here. This is optional, but it does make for a more practical playing solution, and you can get your face a bit away from the instrument so you can actually see the keys. Awesome. So what you're seeing here finally is that the box ends have some holes in them where you can fit M3 screws in, and they go inside the corrugation of the flap and hold everything shut. But I find that the instrument is capable of holding itself shut without those screws anyway. Still, they do no harm. Okay, we're done. Let's plug in this thing and see if it actually works. Not so great. This has gotten a little bit worse since I made the instrument. It's been months now. I think some of this tape has just been compressed. I would probably need to put something a little bit more spongy in between the key and the top side copper tape. It also works fine without the tubes in here. Some of the keys are not super great. Actually, after playing it for a while, it seems like the keys are warming up. I don't know what to call it. But yeah, not quite perfect. Still a little bit of work to do on the contacts here, but it works. So there you go. The second build works. But if I'm being honest, it actually doesn't work as well as the first one. I mean, it looks better, sure, but if that was my main goal, then I wouldn't be making music instruments. Am I right? So there's nothing wrong with the concept as such. The design is executable and functional. The only problem is that some of the keys don't make easy contact, as you've seen. I think the fix is relatively easy, and I will be giving it a go soon and getting back to you, but I didn't want to change anything before I had finished this tutorial. Because I think there's a real lesson to be learned here, and it's one that I truly appreciate. If you're making musical instruments, then functionality is king. Once you have an instrument in your hands and it comes time to make music, it doesn't matter how good it looks. All that matters is how well it responds to you and your input. And yeah, of course, if it's an acoustic instrument, then it has to sound good and all of that. But really, it's just a conduit for the music inside you, nothing more. And honestly, if I had to bring one of these to a gig tomorrow to play for real, I'd take this one. Don't forget, all of the instruments in the KontinuumLAB Instrument Kit also have a companion video, which is published shortly after the tutorial. The companion videos go into more detail about how to calibrate and play the instruments, as well as the different options and settings. So if you're curious about that, there will be a link in the description. And that's all I have for you today. Go check out the other instrument build videos and tutorials right here on the channel. And keep in mind, you can buy the complete KontinuumLAB Instrument Kit as well as various types of instruments in the shop over at KontinuumLAB.com. Take care until next time, and I'll see you in the Kontinuum.